Alright everybody, welcome. Today we're going to be looking at a special case. So sometimes you don't care how high it goes, sometimes you don't care how long it's in the air, and all you really care about is how far does it go. So what we have for you here is our range equation. Range is a fancy way of saying our horizontal distance. So this R stands for horizontal, stick a T in there, distance. The name we give it is range. Range means how far horizontally. V, now here's the nice thing. V is your overall velocity. You don't have to find components or anything. Theta, angle, G, we're going to always use 10 meters per second squared. If you want a little more accurate, you're going to use 9.8. So let us play. So let's do one together. So we're going to say the only question I have is how far does it go? I'm going to launch it at 32 degrees above the horizontal. I'm going to launch at 24 meters per second, and the question we want to answer is how far. We're not answering time, we're not answering how high, so we're not answering a lot of things. So range, always write down your equation first, of sine 2 theta all over g. Now the range is what we're looking for. The velocity, 24 squared, just stick in 24. Sine of 2 times the angle, 64. Gravity's 10. Shoved it into a calculator, and I'm going to get 51.77 meters, which is just going to be 52 meters. That's it. That's how we use the range equation. Two issues are going to come up. On your calculator, you're going to need to be in degree mode. If you've never used sine on your calculator, if you have a TI calculator, you're going to be in radian mode. Ask me in class, I'll show you how to fix it. But hit the mode button and go to degree. Alright, this is the one you're going to practice. How far does a ball go horizontally if it's launched at 40 degrees above the horizontal, 50 meters per second? Pause this, set it up, see how you do. Welcome back. You should be getting 246. Here's the setup. Pause it and look at it if you need it. Alright, now here is the last question. This is the tough one to do. What if I want it to go 52 meters? I know the range I want. The range I want is 52. I can launch it at that velocity. What angle do I fire it at? Well, start by writing down your equation. V squared sine 2 theta all over g. Well, the range I want now is 52. The velocity I have is 39. Sine 2 theta all over 10. Now, just like in math class, we're going to try to solve for this theta. Well, to get theta by itself, we've got to isolate it. So we've got to get this 10 out of here. So I get 520 equals 39 squared sine 2 theta. Well, I got to divide that 39 squared out of there. I'm sure you could stick that in the calculator. You're going to get a beautiful number. But I get sine 2 theta equals, I wrote it down, 0.34188. So I'm going to write this up off to the side here. So sine 2 theta equals 0.34188. Now to solve for that angle on the inside, we need to do something special. What we're going to do is we're going to do the sine inverse of both sides. Just like kind of square roots and multiplying. If I do it to both sides, it's fair. Now let's look at what happens. If I do the sine inverse of sine, they undo each other. How do you do sine inverse though? We'll show you how to do it in the calculator in a second. But when I do that, I'm left with the guts, 2 theta. But to do this in a calculator, you hit second, your second button, and then you hit your sine button. And then you just shove in that value, 0.34188. And I get 19.99 degrees. Here's the problem. That's 2 thetas. So to get theta, I just divide 19.99 degrees by 2. And so I get theta is basically 10 degrees. Alright, you're going to need to know this because we're going to do a dart shoot where you have to find the angle to shoot it at to land it in a specific spot. See you tomorrow in class. Have a good one, guys.